What's up guys, back with another video. I've got something really interesting to show you today. This over here is my router, depending on where you're from, one of them is correct. I'm gonna call it router. It's got OPNsense running, and you might ask me like, hey, I thought this was the router, but you have this. And yes, technically, this is a router. This is a TP-Link AX72 Pro router. It's got Wi-Fi 6. It's not Wi-Fi 6E, but Wi-Fi 6 is good enough. Like, most devices don't have Wi-Fi 6E. I'm going on a tangent. But this over here was a good enough router. It's like $100. It was a good router. Okay, we had some good time. But I wanted to do something different. I wanted to configure like VLANs and get like, you know, OpenVPN running, and I couldn't really do it on this router over here. Like, I could get a VPN connection over here, but it wouldn't exceed like 8 megabit, even though the max speed was theoretically supposed to be like 300 megabit. 8 megabit is just not enough. I knew I had to do something about it, so I did. I built this. It's an AMD Ryzen 3 3200G, that's the CPU. It's a 4-core, 4-thread CPU. It's pretty outdated, it is, but for routers, it's overkill. You don't need more than like maybe 2 cores. Like a good enough router for like one person, 1 or 2 people, doing like not more than like 10 gig. Like a worse CPU would have also been just fine. I didn't need this. 16 gigs of RAM, again, more than 4 gigs is a little overkill. The thing that is really overkill about it is the fact that it's got a 1000-watt power supply. And you might ask me like, what the hell? Why did you do that? First of all, it's not a new power supply. I bought it off of eBay, and people tell you, don't do that. Don't buy used power supplies. They can, like, you know, bad stuff might happen. You know, those capacitors, those things can kill you, like if something is wrong with the power supply. But I was like, I just need a power supply that is like future proof. Like, I want to use it for other projects as well. So I didn't want to get like a 300-400 watt power supply that just, like, you know, it's just not as good. So I got a pretty good power supply. It's like a Corsair one. It was like $60, but like, hey, a 1000-watt power supply, especially from Corsair, is going to be way more efficient than those like cheap 300-400 watt power supplies. So that's what I got. Like, it's a pretty good power supply for the system we are running here. This system probably takes like, I don't know, 150 watts, which is still a lot considering that it's a router. It doesn't really do that much, but like, hey, I'm not paying for electricity, so it doesn't really matter. I shouldn't be saying that. This over here, you might ask me like, why do I have it connected? Why are the wires going to it? Well, this TP-Link router over here is kind of just a WAP, a wireless access point. Even though you might consider a routers to have inbuilt Wi-Fi, that's not really how like commercial, like business routers work. They only do one job, which is like firewall and like, you know, like handling like connections. They don't like handle Wi-Fi. So this computer over here, it's got inbuilt 2.5 gig Ethernet port on the motherboard. So that's really good actually, because my TP-Link router is connected to that 2.5 gig port, and honestly, you don't need more than like a gig for like your wireless access point if you don't have like a really good internet connection. My internet connection only goes to, okay, my face is really red now. The lights went off. Anyway, so my internet only goes to like 300 megabits. So the fact that it's only connected to like a 2.5 gig link is like, it's okay. It's good enough, right? And yes, this router does support, it's got a 2.5 gig LAN port. So that's great. And inside this computer over here, I've got a Intel X540 T2. So it's a network interface card, a NIC. It's 10 gigs. So I've got 2 10 gig ports. 10 gig port connected to a 2.5 gig port. I'm not gonna get like a 2.5 gig link. I'm gonna get a 1 gig link. So hey, if someday I put a 10 gig card inside this server, I'll have 10 gig then. So that's pretty cool, right? I feel like I've been going on for long enough. Let me show you guys what the console for this router looks like. Alright, so this is the console page for the router. This is where you like configure all of your settings. So as you can see, this is the dashboard. There are like a lot of things over here. This is the CPU usage. Most of the times it stays at 0%. I'm not even really sure why it goes up to like 20%, 21% sometimes. I've got 16 gigs of memory. As you can see, I'm using only 5.52% of that. I've got a SATA SSD, and even though it's a really slow SSD, the disk usage is still at 1%, because other than writing a few logs here and there, you don't need a fast SSD for a router. And these are like some interface statistics. These are like some firewall stuff. I haven't gone too in depth into all of this, so I don't really know what it is, but it shows something. It shows something. I'm learning, okay? I'm learning. I just wanted to make this video because this is pretty cool, right? That's my WAN DHCP. That's where I get my internet from. No, that is not my public IP address. That's like the IP address I get inside the WAN. You can't really DDoS me using that. So these are my interfaces. As you can see, WLAN, that's wireless local area network. That's where the router's connected. LAN is local area network. That's where my server is connected. WAN is wide area network. That's where I get my internet from. And this over here, this is a special interface. It's not really a physical interface, it's like a virtual one, because it's a VPN interface. So VPN, TO means, that's my acronym for it. TO means Toronto. So I've got a Azure server running, cloud server running in Toronto, and it's got Pritinal running like over here. And what, if you don't know what Pritinal is, it's OpenVPN, but with a better GUI, with a better interface, and it's easier to use. So it's, first of all, I'm pretty sure it's open sourced and it's free. That's the most important part. And I've been using it for a while, and I think it's just incredible how easy it is to just get your own VPN service running. And you know what's the best thing about VPN services is that if you've got your own VPN, it's like really hard to track you. Like, it's better than, you know, spending like $15 for NordVPN. Just get your own VPN. Like, why do you need to? Why are you paying a company? Just pay a cloud service provider, get your own VPN, and you're good to go. Like, you don't need to pay NordVPN or these other services that can get hacked at some point, and your data might be lost. So I feel like it's better to just like host your own VPNs. Sometimes it's even cheaper. Like, I'm probably paying like $8 or something. It's not that expensive. So OPNsense over here, that's the client. That's all the VPN connections go through the router. That's the one that like manages all of that. So yeah, over here there's like my VPN stuff. So if I were to go here, that's my VPN instance running. And if we were to look at the connection status, so client VPN Toronto client, that's the real address that would be blurred for you, and that's the virtual IPv4 address. So inside the VPN's like subnet, the VPN server, this server over here, gets an IP address of 192.168.221.1 because it's the default gateway, and my router gets 192.168.221.4. So that's how it works. And again, you know what? I'll show you something. If I were to go to, so this is, I've SSH'd into my VPN server, and if I were to ping 192.168.221.4, so that's my OPNsense router. If I were to do that, like I said, it can ping it's taking 41 milliseconds because I'm pretty far away from Toronto right now. If I were to go to, this is my local server, so this is the server over here. I don't know if you can see it in the camera, but you've seen it, right? You've seen that server. So if I were to ping 192.168 a 221.1. So it's going through my server to the router, to the WAN, to the VPN server, and then like pinging it. So as you can see, it's like 40 to 41 milliseconds both ways. So that means it's working. I've got some DHCP rules. So over here, if I were to go to LAN, as you can see, that's my MAC address for. It probably will be blurred for you. But that's the MAC address for the server, and that's the private IP address. And then I'm doing some MAC IP binding, so it only gets one IP address. It doesn't give it like a different IP address every time it connects to the network. Another thing that I want to show you guys is my DNS configuration. So over here, what I've done is I've made it so that if I were to ever go to HDTLS heyday time local server .lan, it would automatically point me to 192.168.0.100. So what that means is like I don't need to type that IP address every time. I can just say HDTLS.lan and it would just take me there. And I've done the same thing for my MacBook. So even my MacBook has got its like own custom domain name inside the internal network. And what DNS stands for, DNS is domain name system. So what a DNS server does is that it maps all of the domains, the domain names, to like IP addresses. So it's kind of like a phone book. Like let's say if I wanted to go to google.com, what the DNS server would do is that it will be like, okay, google.com. Okay, that points to this IP address over here. So you're internally what's happening when you go to google.com, it automatically hits the correct IP address, and it makes your life easier, right? You don't need to remember all of these IP addresses. There are like so many websites. Is it even possible to remember all of these IP addresses? No, the answer is just no. So DNS servers are really, really cool. So I've got some custom DNS configurations for my internal network. So I can actually show you guys. If I were to go to my terminal, if I were to do ns lookup hdtls.lan, it would be, yeah, there you go. So that's my DNS server. So I'm using my router instead of like Google. I'm using my router, but even my router internally like uses Google as its DNS server. But it has the ability to like override some of the configurations that the Google's DNS server has. So hdtls.lan leads me to 192.168.0.100, and if I were to do it for my MacBook Pro, hdtmbp WLAN, because it's on the WLAN interface, it would give me my IP address. So that's really cool. That's like I don't need to remember all of these IP addresses. I can just do this now. I want to show you guys one last very cool thing, and that's my firewall rules. So as I said, I've got a VPN running. So I've got a few firewall rules already. This is the LAN net rule. So what it means is like everything inside the LAN subnet, that includes the server, has access to the default gateway, the WAN. That's where I get my internet. Again, I feel like I've been saying that a lot. But also, I've got a rule that says that this server over here also has access to the OpenVPN server's default gateway. So I can also make it so that my traffic is routed through the VPN. These rules right now are in ascending order. So what that means is like this rule over here will override the rule below it, and that rule over there will override the rule below it. If I were to SSH into my server over here, and if I were to do call ifconfig.io, as you can see, I've got an IP address that starts for 72.33. Now, if I were to change my rule to make it so that it goes first, I could get a different IP address, and it will be a Toronto one. So I'll be call ifconfig. So as you can see, like, yeah, I've got an IP address that starts from 20.63.something. So yeah, I feel like I've shown you guys a lot of just cool things. I'm still learning, so I might have gone over some things like not correctly, or like I might have said something wrong, but I feel like it was an interesting video for you guys to watch. I just wanted to like make a life update video about like what I've been up to, and I feel like routers are cool, and I feel like other people should think the same way. No, not really. I just wanted to do this. I just think networking and firewall rules and NAT and VLANs and VPNs are just like cool concepts, and I feel like if you get into it, you might find it interesting, even though a lot of it just like looks a lot of just it looks like jargon, right? But it's cool. It's cool. As you can see, I've been talking for quite a long time, so that's why I'm kind of losing my voice. So I feel like I should be ending this video. So if you guys felt like you learned something, or I wasn't just saying a lot of things and not making that much sense, make sure to just, give a like, maybe subscribe. I might make another video in 2027, 2028, when I get motivation to do something else, something other than, working with routers. That's about it. See ya.